So Mathcounts week 7 will be circles. The second week of our geometry. We'll be doing this until the 12th week. So there's a lot of geometry ahead. Let's get started. So the topics are, we're going to go over the basics of circles, get an idea of what even are circles. We're going to do tangents, angles inside circles, and then some math counts problems. So circle basics. What even is a circle? Well, we know what a circle is. It looks like this. But what exactly defines a circle? Why is it has to be this shape? Well, a circle is basically if you take a stick and you have a point here and you spin the stick around this point, the other end of the stick will trace out a circle. Okay? So the circle is defined as if you were to take a set length. Let's call this R. If we take the set length R and we revolve it around one point, then it will trace out a circle. This means that all the points on the circle are a distance R away from this point right here. And this is what we call the center of the circle. And the center is a distance R away from all the points on the circle, because that's what a circle is. Because a circle is basically this R revolved around one of its endpoints. Okay? So this is what a circle is. The definition of a circle is that the set of all points equidistant from a center point. That's basically what it is. We have all these points that are the same exact distance away from the center. So that's basically a circle. We also know that in a circle, we have some main parts. The distance R I just talked about, we probably all know that's the radius. The diameter is 2 times that. It goes across the circle. This is D, diameter. And the length of the circle, or the perimeter of the circle, or like the fancy word is the circumference of the circle, that is going to be 2 times pi times r, and pi is just this special number 3.1415, whatever, okay? So that's the circumference. And the area of the circle, which is all the stuff inside it, that's going to be pi r squared. I think most of you, or if not all of you, should know this already. Okay, so those are the basics of the circle. We're not going to go that further into the area and perimeter for now because we have a whole class designated to those two topics later on. So tangents. What are tangents? I have a visitor here. Okay, so what are tangents? A tangent to a circle is a line or anything that intersects the circle at only one point. So if I were to have a line here, for this line to be tangent to the circle, it can only touch the circle at one point. If the line went through the circle and touched at 2 points, that's not a tangent, okay? And not just lines can be tangent to circles. Not just lines. We can have circles tangent to circles. As long as these circles only touch at one point, they're called tangents to each other. A circle can be tangent to a square, okay? So the definition of tangent is that it only touches the circle at one point. And the cool thing about tangents is the most important thing is if we were to take the contact point, you would draw a line to the center of the circle like this. This is a pretty bad line. Draw a line like this. Then this line, the radius right here I draw, is perpendicular to the tangent, 90 degrees. Okay, that's probably the most important thing that you should know for this class. Tangents always make 90-degree angles with the radius if you draw it to the center, okay? For example, right here as well, if I draw to a tangent, it's gotta be perpendicular. If I have a circle inside a triangle, like this, we call this an inscribed circle because it's inside the triangle. At all the points here, if I were to draw a radius, it will be perpendicular to all the sides because it's tangent to all the sides, okay? So that's the most important thing about tangents. Another thing about tangents is that if we were to take a point outside the circle, let's say this point, and we can only draw 2 tangents at maximum to the circle. One can be like this, one can be like this, okay? So for any point outside the circle, we can only draw two tangents. And these two tangents actually have the same length. So this has length L, this must also have length L. So that's another really important thing. If we have two tangents to a circle coming from the same point, then those two tangents, if we take a distance from the point to the contact point, those two distances must be equal, okay? So any questions about tangents? So the two most important things you need to take away from tangents is that any tangent is perpendicular to the circle, and also if we draw two tangents from one point outside the circle, they must be congruent or equal. Now we've got these two problems here about tangents. I'll give you guys about till 8:14 or 10:14. about this? I'll go over the first one, and then that might give you a good idea how to do the second one. So for the first one, we want to find this length x from the point all the way out here to the center of the circle. So what we want to do is we want to draw out, well, we know that the tangent has to be perpendicular to the radius if we draw it from the contact point down to the center. So let's draw that. That's going to be perpendicular. That's going to be perpendicular. We know that the radius is 6. And if you can see here, we've got right triangles. Let me use the highlighter. This is a right triangle because it's got a right angle, right? It's a right triangle with legs of length 6 and 10 with the hypotenuse of length x. So we're going to use the Pythagorean theorem. It's going to be 6 squared plus 10 squared equals x squared. It's going to be 136 equals x squared. So x is going to be the square root of 136. And you can just leave it like that. I don't really need more simplification, but on the test, they would want that. So if we simplify this, we can take a 4 out. This will be 4 times 34. And this 4 gets taken out of it, so it's going to be 2 square root 34. That's going to be x. But if you just left it at square root 136, that's fine with me. Okay, so that's how you do the first one. Then now use that idea to take a shot at the second one. Alright, so for the second one, we're going to want to do a very, very similar thing. We know that this circle is going to be tangent to all 3 sides of the triangle. So let's draw the radii that go in. We know that they're going to be perpendicular. This one also perpendicular. So now what does this tell us? Let's first label all the radii. Now what? Well, if we look at this shape right here, this shape has got all right angles, and it's got 2 sides of length r, so it's a square. So you got a square right here. If you know that length is r, then we know that this length is going to be 8 minus r, because you can see that, right? That takes a chunk of r out of 8, so that's all I have left. Similarly, right here we have this chunk is going to be 15 minus r. So now we're going to use the property that if we take a point and we stretch tangents to the circle, these tangents are going to be congruent. So if this is 8r right here, this is also 8r, 8 minus r. Okay? Right here as well. These are two tangents from the same point right here. So this is going to be 15 minus r. You can see that 8 minus r and 15 minus r, if we put them together, they make 17. This is going to be 8 minus r plus 15 minus r equals 17. So what's r going to be? Well, we got, let's first add these two together. So we're going to get 23 minus 2r equals 17. If we move the 17 this way and the r that way, then we're going to get 6 equals 2r. R is going to equal to 3. Okay. So the trick was to draw out all these radii. If you don't draw them out, then you'd have no idea what to do, right? So whenever you encounter a problem where you have tangents to a circle, draw as many radii as you can and make them perpendicular to the tangents. Okay? Well, we're going to go on to angles in the circle now. So first of all, we have an angle in a circle. The basic angle we can have is if we take the center and we make angles from the center. All right? Let's say this is x. Note how in circles, this angle is going to cut out this length of the circle, this portion of the circle. And since a circle is perfectly rounded, we can call this is called an arc. And the arc, we don't measure its length, actually, we measure how many degrees it has. And the arc is going to have x degrees, okay? So this is basically like, if we were to take the entire circle, the length of that arc is going to be 360 degrees. Okay, so the arc measure, we measure arcs with degree lengths, and the degree lengths of the arc equal to the degree length of the angle we make if we take it from the center. Okay, but we don't always have to take angles from the center. What if we took an angle from the opposite side of the circle? Right, the center is right here, but the angle we have is right here. So how do we do that? Well, if this is an x, this is the arc length x. We're going to use these arc lengths to find out what this angle is. So we have many types of angles. So this is one type where the angle is centered at the opposite point on the circle. We also have a scenario where the angle is inside the circle, but it's not at the center. This is the center, then the angle is going to look like this. All right, it's in the circle. And this angle is going to actually cut off two arcs here. All right, we have one arc, two arcs. So what else do we have? The last possibility is that the angle is outside of the circle. This is also cutting out two arcs. 1, 2. So we have formulas to tell us what these angles are for each of these three scenarios. So for the first scenario, if the angle is on the circle and it cuts out one section of arc length x degrees, then this angle is going to be equal to x divided by 2 degrees. So if this arc length was 30 degrees, then this angle would be 15 degrees. For the next one, if the angle is centered inside the circle, anywhere inside the circle, it could be here even, and it cuts out these sections, okay? Any angle inside the circle is going to cut out two sectors, two arcs, and the angle is going to equal to arc 1. I'm just going to call this A, B, okay? A plus B divided by 2. So the angle is going to be equal to the average of the arcs it cuts out. So this is if the angle's inside the circle. We also have the last scenario where the angle's outside the circle. This one also cuts out two arcs, but the formula for this one is going to be equal to, let's call this A and B again. It's going to be B minus A divided by 2. So the larger arc minus the smaller arc divided by 2. So this is with any angle outside the circle. So this angle could be right here, it could just cut out like this, and this formula would still apply. Okay? And for this angle as well, if we were to take another point on the circle, as long as it's on the circle and it cuts out this arc, it's also 15 degrees. If we take out from right here and it still cuts out this arc, 15 degrees. Okay? So for on the circle, it's x over 2. Inside the circle, it's the average of the arcs it cuts out. Outside the circle, it's the bigger arc it cuts out minus the smaller arc divided by 2. Any questions? Cool. So the last scenario right here, this is the most basic scenario. If the angle is centered at the center of the circle, then the angle length is equal to the arc measure. And that's how we define the arc measure. Okay. The arc of length degree, let's say if we have an arc of degree 100 degrees, then the angle from the center must equal to 100 degrees because that's how we define the arc. Okay. So that's how we do angles in a circle. We have 2 problems here. Oh, oops, what happened there? You guys still see my screen? Something messed up there. All right, so 5 minutes for these. Actually, I'm only going to give you guys 3 minutes for these because these should be pretty straightforward. So let me go over the answers now. So for the first one, this angle is cutting out a 30-degree arc, and this angle is on the opposite side of the circle. It doesn't matter where it is, as long as it cuts out this 30-degree arc, we don't care where it is. It's always going to be 30 degrees divided by 2. So that's the formula for this angle on the circle. So 30 divided by 2, x is just going to equal to 15. This one's a little bit more tricky because we have one arc. We want to find one arc. X is one arc, but we don't know what this arc is. How do we find out what that arc is? Well, 50 is right here. 50 is at the center of the circle. So what that means is that this arc has, by definition, has to be 50 degrees, because that's how we define it. So now I've got to go backwards. This angle of 10 degrees cuts out 2 arcs. So the bigger arc minus the smaller arc divided by 2 equals 10. So 10 equals the bigger arc minus the smaller arc divided by 2. So we're basically using the formula backwards now. We already found the angle. We want to find one of the arcs. So now all you can do is solve for x, multiply both sides by 2. 20 equals 50 minus x. So x is just going to equal to 30 degrees. Okay? Something that's a little more difficult here. Yeah, so take 3 minutes for this problem. Alrighty, so for this one, we want to prove that in the cyclic quadrilateral, angle A plus angle C is 180, angle B plus angle D is 180. Well, the first thing we should notice is that all the angles in this quadrilateral are on the edge of the circle, right? A is on the edge, C is on the edge, D, B, okay? So to find the measures of these angles, what we're going to do is we got to analyze the arc they cut out, right? Because we know these angles, the measure of these angles are going to equal to the arc divided by 2. So let's first look at A. What is the arc that A cuts out? Well, A cuts out this arc. Okay. Let's look at C. What arc does C cut out? Well, C cuts out this arc. You see that? Because the angle C right here, that's cutting out that arc. So now if we have that, observe how the arcs that angles A and C cut out make a whole circle. So let's say arc A is going to be A, and this is going to be C. Arc A plus arc C equals 260 degrees. All right? We know that arc A equals 2 times the actual measure of angle A, right? Because we know that arc A divided by 2 equals A. So arc A equals 2A. Arc C equals 2C. So we plug these in, we got 2A plus 2C equals 360. Divide through by 2 on both sides, we got A plus C is 180 degrees. And you can prove that in a very, very similar way with B and D, because B also cuts out this kind of arc, and D cuts out this arc. And they also make 360 degrees with their arcs. Any questions? Cool. So we're going to go on to some Mathcounts problems now. And here are some 4 most important tips you can have for Mathcounts circle problems. So first of all, draw as many relevant radii as possible. Okay? So it doesn't matter if they're going to be useful or not in the end. Draw as many radii that you think should be useful to solving the problem. Okay? Secondly, find tangents. So if you see tangents, draw all the radii that make the circle perpendicular to the tangents. Okay? And then if you have these right angles that you make with the radius and the tangent, then you can find right triangles. And then once you find right triangles, use the Pythagorean theorem to solve for what you want. So that's basically the general process that I would basically try on every single Mathcounts circle problem, because for all the 3 Mathcounts problems we're going to do, you're going to have to go through these 4 steps. Okay? So it's a very, very common type of problem, or like a common procedure, or common, basically you have to have a common procedure for all these Mathcounts problems. Okay, so this is basically the general kind of Mathcounts circle problem you're going to encounter. So yeah, these 4 steps. First, draw as many relevant radii as possible. So let's say we have, just as an example, we have a circle inside a triangle. So first, we're going to have to draw as many relevant radii as possible. Well, let's draw them to the sides of the circle, right? And we know that these are tangent. So let's draw out these right angles. So now find right triangles. Well, if we draw a line down here, we have this right triangle, this right triangle. Draw a line here, we have this right triangle and this right triangle. Draw a line right here, this right triangle and this right triangle. Okay, so we got all those right triangles. Now, whatever we want, we can pick one of those triangles to use to help us solve for whatever we need. Okay, so those are the 4 key tips for Mathcounts circle problems. Let's go on to the problem. So first problem right here. 5 minutes for these. For this one, you can assume this is a rectangle, this is a rectangle, this is a half circle. Okay? They're not written in the problem, but you can assume those things. Wait, actually, I think I did not give you guys all the information for this one, so let me first Okay, so how about this? Well, I fixed that problem. Do the second one for now. Okay, so let's do this one. I'll get the rest of the information for the first one. We'll go back to that one later. Okay, so let me go over this one now. So the first step is we want to draw as many relevant radii as we can. Well, we know that the circle is tangent to the sides of the square, so let's draw those. These are going to be perpendicular. What else do we have? Well, we have the semicircle, and the semicircle and the circle are tangent to each other. So if we draw a line to their centers, then this is going to equal to r. This is going to equal to the radius of the semicircle. The semicircle has a diameter, that's the side of the square, which is 4. So the radius is 2. So this length here is going to be r plus 2, if the radius of the circle is r. Let's label all these r's as well. So now the third step is we want to find right angles and right triangles. Well, it seems like this r plus 2 might be the hypotenuse of some right triangle, but we don't see it yet. So how do we make it appear? Well, we know that this length is r. So if we draw a dotted line down here, so this is r as well. We have a perpendicular that goes down to the square. Now we have a right triangle. Do you see that? We found a slanted line that looked kind of like a hypotenuse, and we drew down a line to make it our triangle. So now we got to find the legs of the triangle, right? So then we can make an equation to solve for r. Well, since this is r right here, and this is 2, because it's the radius of the semicircle, this is r2 minus r. Right here, one leg. The other leg, well, the side length is 4. This is r. So this length is going to be 4 minus r, which is the other leg of the right triangle. So we've got 4 minus r squared plus 2 minus r squared equals 2 plus r squared by the Pythagorean theorem. Now we've got an equation. We can solve for r. So let's expand all of these. This is going to be r squared minus 8r plus 16. This one's going to be r squared minus 4r plus 4. This one's going to be r squared plus 4r plus 4. Well, we've got r's on both sides, r squares on both sides. We can cancel those. What else do we have? We have a 4 on both sides. We can cancel those. Doesn't seem like we can cancel anything else. Let's move this 4r here. So we got 0 equals, well, it's going to be negative 8r minus 4r minus 4r, which is going to be r squared minus 16r plus 16 equals 0. We can't factor this, so let's use the quadratic formula. It's going to be negative b plus or minus the square root of b squared, which is 16 squared, minus 4ac, 4 times 1 times 16, all over 2a, which is 2. 16 squared minus 4 to the 4 times 16, well, we can simplify this a little bit. It's going to be 16 times 16 minus 4. Okay, because we took the one of the 16s out. It's going to be 16 times 12. Okay. Well, in the square root, 16 is 4 squares, so we can take the 16 out of that. That just equals to 4 outside of the square root. Let's simplify a little bit. This goes away. This turns into 2. This turns into 8. 8 plus or minus 2 square root 12. Well, square root 12, that's just square root 4 times 3. 4 can take out. 4 turns into a 2. It's going to be equal to 8 plus or minus 4 root 3. But we can't have two solutions. There can only be one solution. So which one is the right solution? Well, if we look at this, 4 root 3, 8 minus 4 root 3, that's positive. 8 plus 4 root 3, that's also positive. So it's not like any of them are negative, so we can still consider both of them. So which one is the side length? Well, 8 plus 4 root 3, that gets really, really big, right? 8 plus 4 root 3, that's going to be bigger than 4. But the radius r cannot be bigger than 4 because it's inside the square. So we can only take the 8 minus 4 root 3 solution. It's just 8 minus 4 square root 3. And that's the answer. All right, so you can see how I drew out all the relevant radii, made them perpendicular to the tangents, and then try to find right triangles to solve the Pythagorean theorem with. All right, let's do one last problem here. I'm probably going to go a little bit over time, but that's fine. I'll give you guys 5 minutes for these. Actually, let me give you guys a hint here. I'm going to do the first step for you. I'm going to draw all the relevant radii, so you know which radii are relevant. Well, these tangents are. And then since these two circles are tangent to each other, we can draw out this here, R and R. So those are the relevant radii. So now try to solve for R. Okay, so I don't want to keep you guys too long. So how do we do this one? Well, right here we can see that this 2R segment, if we'd extend it out this way, they would make the diagonal of the square. All right? If we do that, it's going to make the diagonal of the square. So what happens here? Well, the diagonal of the square, if we have these set as D, then the diagonal of the square is 2R plus 2D equals the diagonal of the square. And we know what that is because the square is side length 4. So the diagonal is going to be 4 times the square root of 2 if we see this right triangle right here. Okay? So we know that 2R plus 2D equals 4 square root 2. Now we got to find what D is, right? So what is D? Well, if we see here, we've got squares right here. Squares of side length R, and D is the diagonal of this square. So D is going to be R times the square root of 2. So if we do this, 2R plus 2 times R square root 2 equals 4 square root 2. Let's factor out an R right here. So this actually, let's cancel out these. So it's going to be R 1 plus square root 2 equals 2 times the square root of 2. Divide both sides by 1 times plus square root 2. r equals 2 square root 2 over 1 plus the square root of 2. And that's your answer. You keep it as that, or you could simplify it a little bit so you get all the square roots on the top. I don't really need you guys to know this right now, but if we multiply the top and bottom by 1 minus the square root of 2, we cancel out the bottom because 1 times 1, this is the difference of squares. It's going to be 2 square root of 2 minus 2 square root of 2 times square root of 2, which is 4 over 1 minus 2, or negative 1. Negative 1. So it's just going to be equal to 4 minus 2 root 2. Also an acceptable answer. This or this, both acceptable answers, okay? So that's it for today. I know these problems were a little bit hard, but these are the kinds of problems you're going to see on the Mathcounts test. All right? So that's it for today. See you guys next time.